Hi everyone, today I will explain chapter 7 Inference of Wave. You may have sensed that you can clearly hear a person's voice, even though his voice intersects with other voices. Constructive interference. When the waves overlap, a reinforcement occurs in the resulting wave called constructive interference. At interference of the junction or peak of the wave with another wave peak or junction of the two wavelengths. For example, if you look at it, it has the two frequency and wavelength. These two frequencies when it is connect each other. First, look at this A1 and 2. Look at this starting point, start point. It is same wavelength. When we are adding it together, it will be two times same wavelength. It will be bigger. But destructive interference opposite meaning the firstly. Where the waves cancel the effect of each other, such as the confluence of the peak of the wave with the junctions of the another waves. Look at it is same wavelength, but look at this starting point, it is moving down, but this one is moving up. Look at this opposite. These two wavelengths, when they are connect each other, look at this up first, secondly down. It will be cancelled. If a periodic external force is affected in vibrating system and influence force frequency, we can show the F, is equal to the normal frequency of, we can show F0. That is, it means F equals F0. And resonance, the relative amplitude, if you remember about the amplitude of the system vibration is increased, it is then say that the force is in resonance with the system, and the frequency in this case is called resonance frequency, and that the system has the maximum force. Look at this, it is balancing or resonance point. And beats if the two tongues rang with the slightly different frequencies, then we will hear a voice of varying intensity, and this phenomenon is called beats. For example, two tongues and the frequency of the beat we can show FB equal to a difference between the sources frequencies as following the equations. FB equals F1 minus F2. The wavelength frequency F resulting from the wave overlap is equal to the average frequency of the wavelength. If you have the two wavelength, it has the two frequency and beat frequency. And look at this. If do you remember, look like this figure in the mathematics lesson, arithmetic ratio. Average frequency, first one and second frequency is over 2 because of it has two frequency. If it has the three frequency, we will over 3. Example 6. It is instead of the set of the frequency of and tuning the fork near another vibrating one of the frequency 446 Hz, which has the here from its 7 beats over second. How much the frequency of the unknown fork? Firstly, I am writing the given. It is giving the FB equals 7. and another frequency is 446 Hertz. But this one is F1 or F2, we don't know. We will try and we will find the both of them is. First I am writing our equation FB equals F1 minus F2. First, if F1 is 446 Hertz, we will find F2. 7 equals 446 minus F2. F2 equals 446 minus 7 equals 439 Hertz. Firstly, this one is. But if 446 Hertz is F2, I would writing the same equation, writing 7 equals F1 minus 446. F1 equals, this is minus, when we are sending another side it will be positive. 446 plus 7 equals 453 Hertz. F1. Standing waves. Standing waves, the amplitude of the vibration, energy and velocity of the medium particle increase between each two nodes, and the largest amplitude is at mite distance between each successive nodes. We are called ventricles, and place these bellows and nodes are fixed, so these waves are called standing waves or static, which are called the bellows, and the place of these bellows and nodes fixed, so these waves are called standing or stationary waves. For example, firstly, it is look like one waves. If you look like this figure, F equals F1, but and using delta equals to L. But if you look like this figure, it has the two wave F equals to F1 or wavelength equals L. If separated 3, F equals 3F1 or wavelength equals 2L over 3. Depending on your answer below the question, then straight line L, the totally, the number of bellows, and multiply wavelength over 2. L equals N multiply wavelength over 2. Questions. In the figure, in the book, they wrote the figure, but it doesn't have figure. But you are not need the figure. A string of length 42 centimeter. I am writing the given which a standing wave of 6 bells and speed is 84 meter per second was generating to find the wavelength, and the first and second is important. Now I am writing the given. L equals 42 centimeter and N is 6 and wave speed equals 84 meter per second. Now I am writing the equations. Firstly, L equals N multiply del wavelength over 2 equals, it is centimeter, we must change meter, or we must convert the centimeter to meter. 42 centimeter equals 0.42 meter equals N is 6 multiply wavelength over 2. Wavelength equals wavelength equals 0.14 meter. We find this one. Now we will use it for frequency. Frequency equals n multiply speed over 2L equals, or F1 equals, firstly it is first harmonic motion, 1 multiply, what is the speed? 84 over 2 multiply L 42, or 0.42 meter. 0.42 meter equals 100 hertz. And second harmonic motion, I am using the same equation. F2 equals 2 multiply, this is second harmonic, and speed over 2 multiply L is 0.42 equals 200 hertz. Sound characteristics. The voice differ from each other with the three base characteristics. Firstly, loudness, second, pitch of the sound, and type of sound or sign types. Firstly, loudness. The loudness of sound is strongly related to the sound that has an effect in the R, it's meaning between the distance, that gives us a sense of loudness or lowness. The time average of acoustic energy to unit vertical area of the wave, which is centered at that point. And sound sensitive equals acoustic power over area. Sound sensitive we can show I. Also, you remember power is capital P and area capital A. P acoustic power and unit of the power equals watt, and area, unit of the area meter square, and sound intensity measuring watt over meter square because of watt over meter square. The intensity of the sound at the point of the middle depends on, we have the four main kind of. Firstly, the distance of the point from the source. Second, the amplitude and the frequency source vibration. And third, sound area of the vibrating surface. And fourth, intensity of the propagation medium. Firstly, the sound intensity at the particle point is inversely proportional to the square of the distance between the point and sound sources. Secondly, the sound intensity is direct proportional multiplication to each of the square of amplitude vibration sound source as well as to the square of the source frequency. And third one is the intensity of the sound increases as the surface area of the vibrating body increases. Last one is the intensity of the sound increases as the intensity of the vibrating medium increases. And mirroring sound levels. The human ear senses the intensity of the sound about 10 power negative 12 watt over meter square until 1 watt over meter square when the sound frequency is 1000 Hz and the intensity 10 power negative 12 watt over meter square was considered to be the beginning of the hearing, and it was called the hearing threshold, and a logarithmical scale was used to calculate the level of intensity of the sound of intensity. We can show I. And about we are measuring the sound levels, we must know, you learned in the mathematics lesson, logarithmic scale. And for example, our equations, L, do you remember? Intensity sound levels, and decibel unit of sound. We can show D capital B shortly equals 10 multiply logarithm of 10 inside first over second. What is the L? What is the L0? L0 represents the hearing the threshold of watt, and secondly represent the level of the intensity is measuring decibel. And it should be noted that level sound intensity at the threshold of hearing is 0 because of L0 equals 10 multiply logarithm 10 power negative 12 over 10 negative 12. 10 power negative 12 over 10 power negative 12 equals 1. Logarithm of 1 equals 0. Logarithm of 1 equals 0. And since the greatest intensity that ear can hear is 1 watt over meter square, then highest level of acoustic intensity at the point threshold is, we can find L0. L0 is acoustic intensity sound levels. 10 multiply logarithm 1 over negative 12 over 10 power negative 12. You know 1 over 1 power negative 12 equals 1. It's meaning 10 multiply logarithm 10 power 12 equals 10 power 12 equals 12. I am writing logarithm 10 power 12 equals 12. 12 multiplied 10 equals 120 decibel. And some example of intensity level of different sound sources, and they are showing the how much decibel. For example, here near jet airplane 150 decibel, and also Siren Rock concert 120 decibel, and subway power mover 100, and bus traffic, and vacuum cleaner normal conservation, and mosquito buzzes 40, whisper 30, and rustic levels 10, and threshold of hearing 0 decibel.